This video is for Math 63, and this is our last assignment on dosage calculations. I have a couple of new units, and this is, I recommend that you look at the last page of the assignment first. So we've got this information: micrograms are abbreviated mcg, milligrams are abbreviated mg, and then we have grams and kilograms. Okay, let's see here, what else? Milliliter, a cubic centimeter. A cc is a cubic centimeter, and it is just what it says it is. It is it's a cube, that's 1 centimeter on each side, and by definition in the metric system, that holds 1 milliliter. Okay? And so 1 cubic centimeter is the same as 1 milliliter. And these are used interchangeably in a lot of situations. And so it's good to be familiar with the fact that they are the same thing. 1 milliliter is the same as a cubic centimeter. So in terms of conversion, let's see, I think the relationship holds for all of these where you get 1,000 micrograms is 1 milligram, and then 1,000 milligrams is 1 gram, and 1,000 grams is 1 kilogram. And so I've got all that information there for you on the handout, along with the facts that a milliliter is the same as a cubic centimeter, 1,000 milliliters makes a liter, and consequently 1,000 cc's also makes 1 liter. Okay, so there's our starting information. Let's start to work through these problems. A lot of this is going to involve information, I think not so much about percentages, but a lot of stuff about proportions, and some conversion of units as well. So let's look at problem 2. Let's see. We need 30 milligrams of codeine for a patient. The medicine comes as 60 milligrams per tablet. Okay, and you see that slash mark there? That is the same as the word per, and it means you can write this as a fraction. 60 milligrams is 1 tablet. Now you might just look at this problem and say, oh, well, we need half of that, right? So we need half a tablet. In the end, if you want to, if you're not sure, here's the proportion, right? Set it up on opposite sides of the equal sign, match up your milligrams, match up your tablets, and then multiply these two and divide by the 60. X is 1/2 of a tablet. Okay, let's take a look at problem 4. We need 1,000 micrograms, and that's 1 milligram, just to remind ourselves, of vitamin B12. The medicine comes as 1 milligram per milliliter. How many milliliters should be given? Well, I kind of gave it away by automatically converting this into milligrams. So if we want 1,000 micrograms, then that's going to be 1 milligram, and if it comes as 1 milligram per milliliter, then that's all we're going to need, is 1 milliliter. Okay. Let's keep working on these. Problem 6. Okay, so we've got this medicine in suspension 10, yeah. So the amoxicillin is prescribed as 10 milligrams per kilogram of body weight. Okay, so that's a frequent dosage recommendation, is how much of the medicine per kilogram of the patient's body weight. Ordered for a patient who weighs 44 pounds. Okay, well, we're going to need to convert that into kilograms because that's how this information was given to us. So let's do that first, okay, and then we'll continue working our way through the problem. So from our conversion sheet, we know that 1 kilogram is 2.2 pounds. So if we have 44 pounds, how many kilograms will we have? Well, we've got to do 1 times 44 and then divide by 2.2. And it looks like X should be 20 kilograms. Okay. All right, now let's go back to the problem. So let's see. Well, let's figure out how much of this medicine we're going to need then, right? If it's 10 milligrams per kilogram, if this person's 20 kilograms, we just need to multiply by 20 here. We can set up another proportion if we want to, right? 10 milligrams per kilogram. If somebody's 20 kilograms, how many milligrams will they need? So there's the 200 equals X. So 200 milligrams. That's what we need. Did we answer the question yet? Oh no. The medicine comes as 250 milligrams for every 5 milliliters of solution. So how many milliliters are we going to need here? Well, now let's set up another proportion. So, let's see here. We need 200 milligrams, and we want to know how many milliliters of solution will be required if we're getting 250 in every 5 milliliters. So, multiply these two and divide by 250, and that'll tell us what we need to know. I think it's going to come out to be 4 here. If you look at the way this is structured, 200 times 5 and then divided by 250, yeah. So we're going to need 4 milliliters of solution to make that, to get that 200 milligrams of amoxicillin. Okay. All right, well that was an interesting one. There was a couple different places where we had to use proportions, and that's frequently the way these problems are set up. All right, heparin concentration, 30,000 units per 1,000 milliliters. Okay, and we could reduce that. You know, we could say this is 30 units per milliliter if we wanted to. I'm not sure if that'll be helpful or not. You are ordered to give 900 units per hour. At what rate will you set the IV pump? Okay, so that means how many milliliters per hour are we going to need to get this 900 units? Well, now once we've reduced this, let me double check that I wrote down that correctly. Yeah, now that we've reduced this to 30 units per milliliter, you could just divide 900 by 30, and that says that we should be getting 30 milliliters. But the way to know that that's the correct method is we can set this up as a proportion, 900 units in X milliliters, and you would do 900 times 1 divided by 30, and that would be 30 milliliters. So, 30 milliliters per hour, that's what we want to set it for. Okay? Because that will deliver 900 units per hour. Okay. That's problem 8. Problem 10, more heparin questions here? So, problem 10, we're looking at 20,000 units per 500 milliliters. The pump is set at 15 milliliters per hour. The patient is receiving how many units per hour? So the question is, how many units are in 15 milliliters if we know that 20,000 units are in 500 milliliters? And we could play around with this the way that we did in that last problem, but let's just use the information that we're given. 15 milliliters should go down here, and we're interested in how many units will be in those 15 milliliters. Notice that the hours I've just kind of taken out for the moment because we need to find out, we're really interested in units and milliliters, and that's what's in the proportion. Okay, so let's see here. I got to do 20,000 times 15, and then divide that by 500, and that tells me we should be getting 600 units per hour. Okay. Well, let's keep going here. Problem 12, 1 gram of erythromycin. You have erythromycin as 250 milligrams per 5 milliliters. How many milliliters of suspension do you need to give? Okay. Well, first we need to check out our units here. Right, this one's in milligrams, this one's in grams. So let's make them the same units. Okay, it's pretty straightforward. So now you can do this by inspection. I'm looking at this. I see we need 1,000 milligrams. We get 250 and 5 milliliters. So we need 4 of these, right? And that'll be 20 milliliters. We can go ahead and set up a proportion to double check. And I do that sometimes, when I'm solving problems, is I look at it, see what I think the answer is going to be, and then if it's important, I'll go about it the long way and find out whether or not I was correct. Okay, let's see here. So 5 times 1,000, and then divided by 250, and that gives us 20. X is 20 milliliters. Okay. Problem 14. Let's see here. Problem 14. Or more concentrate 100 milligrams in 5 milliliters is used to give a dose of 60 milligrams for breakthrough pain. How many milliliters will we need? And again, we can go ahead and set up our proportion here. If there's 100 milligrams and 5 milliliters, then how many milliliters will have 60 grams in it? And so we need to do 5 times 60 and then divided by 100. And that says we're going to need 3 milliliters to get that 60 milligrams. Okay. Got a couple more here to look at. Problem 16. A lot of these medicines I have heard of before. This one I've never heard of before. Ranitidine liquid. 2 milligrams per kilogram. Okay, so there's our dosage. 2 milligrams for every kilogram of body weight. We're going to give this to somebody who weighs 23 kilograms. So that means we're going to need 46 milligrams of medicine, right? Because if we just multiply these, right, we need 2 milligrams for every kilogram. If we've got 23 kilograms, 23 times 2 says we're going to need 46 milligrams of medicine. Okay, so that gives us some starting information. Now we've got 150 milligrams in every 10 milliliters of liquid, and we need 46 milligrams, and I'm kind of getting ahead of myself here. How many milliliters do we need? Yes, and this is going to turn out to not be a whole number, and so we'll just round it off to the nearest milligram. So we do 10 times 46, divide that by 150, and so this turns out to be about very, very close to 3 milliliters. Okay, that's problem 16. We've just got 2 more here. Problem 18. Aminophylline, another one I haven't heard of before. Aminophylline. Injection, 250 milligrams per 10 milliliters. The amount required is 350 milligrams. So let me just go ahead and set up a proportion here, 350. Then how many milliliters are we going to need? Okay, so let's go ahead and go 10 times 350 and then divide that by 250, and so X is going to be 14 milliliters to get that 350 milligrams. Okay, last one, problem 20. Morphine sulfate, 10 milligrams. 10 milligrams in 5 milliliters. And we need 15 milligrams. Okay? Well, if you can see how this is going to work out, this is going to be 1.5 times. So 1.5 times that would give us 7.5. But let's set up a little proportion here. And again, remember, on opposite sides of the equal sign, we need to match up the milligrams, match up the milliliters. And once we do that, then it's pretty straightforward. 5 times 15 is 75. And then if we divide by 10, there's our 7.5 milliliters to get that 15 milligrams of medicine. Okay. So like I said, this is the last assignment for the course. These problems are kind of a culmination of a lot of the major things that we've talked about during the term. All these measurement conversions, setting up proportions. So all of that comes into play when we're doing these dosage calculations. Let's see here. I just sent out an email asking people to make appointments to take their final exam. And as always, if you have any questions as you're working through these, please let me know. Thank you.